Hi guys, welcome back to John's Workshop, and this is the next episode in the mill head strip down. So I'm going to take you a bit further into the sort of further strip down of the bearings off the shafts, and through the next bit of the process of the clean up, ready for the rebuild. So I'll bring you back in a moment at the bench, and we'll go into a bit more detail with the strip down. Right, welcome back to part 2 guys. So what I'm going to do first initially is I want to further strip these shafts down and get the bearings all off, and get them measured up so that I can then start doing some research and get the new bearings on order, because they may take some time to come, so I want to get that job done first. So what I'm going to do is I've laid the shafts out as in primary, secondary, tertiary, and then final drive. So that's the order that they run in, from power input at one end to power output down the spindle at the other. So I'm going to mark these up as shaft number 1, number 2, number 3 and number 4, and then I shall mark them with a 1 and a T for top bearing and a 1 and a B for bottom bearing, pretty much like that, and the same across the rest of the shafts. So I'm just going to, on each one of these, I'm going to mark them up first. So I'm just going to use a bit of methylated spirits on each one. So we'll start with the primary shaft, and basically I'm just going to clean a small area of the bearing surface up just to get rid of the oil, and then with a permanent marker I'm just going to mark on there. So that's shaft number 1, and that's the top bearing, and basically I'm just going to do that through all the bearings. So I'll get them all marked up, and then we'll get on with trying to remove the bearings off the shafts, and I'll bring you back when we get to that point. Right guys, I'll just do this one on camera just to kind of show you what I'm doing. So I'm holding the shafts in the vise. I've marked all the bearings up now with a correct sort of nomenclature on it, so I know which one's which, and basically I'm just using 3-legged puller on each bearing, and these pullers aren't brilliant to be honest, but hopefully they're going to do the job, which they do. These were dirt cheap pullers, and I've had them for, oh God knows, 25 years probably. $4.99 from Enoch's, so you can tell they're a quality tool. I don't know who Enoch was, but he relieved me of a few pound many years ago, but I'm glad he did, because where you can get in, where you can get access with these are pretty bulky to be honest. They're really for gears, pulling gears rather than bearings, but it just makes the whole job much easier. So what I am going to do with these, some of these are better than others, so I'm going to, once I've measured everything up, and you can see I've marked that one up there 2T, so that's obviously the second shaft and the top bearing. What I am going to do with it, I'll keep the best ones, and I'm going to make a pushing tool for the lathe at some point as a mini project, for squaring up stock in the lathe when you're only holding on a very small amount near the front of the jaws, and these will be perfectly good enough for that. You know, they're no good in a milling machine. This one's pretty good actually. It's a little bit of a rumble in there and a little bit of play, but it's probably one of the best ones is that one. But one of the other ones I took off, this one, I don't know whether this will on camera, but you can just see when I'm spinning it, look, I don't know whether it'll show up, but when I spin it, it's just stopping. You can see it kind of jump in between where the balls are. It's just really rough, really rough. So yeah, some of them are rubbish and will just go in the bin like that one, but the best ones I'll keep and make a little pushing tool with, and that'll be a project for YouTube. So I'll bring you back once I've got all the bearings off, and then the next part of the whole thing then will be the spindle itself, the main quill, getting the taper roller bearings out of that, which is going to be I think that'll need a bit of brute force to get those out, but we'll bring you back when we get to that point. Alright guys, that's got all the shaft bearings done. So you can see I've laid them out there, shaft 1, shaft 2, shaft 3 and shaft 4, top and bottom marked on all of them. Good job I didn't film all of that, because there's been some quite bad language on a couple of them, but we got there in the end. So I had to employ some different tactics. The puller that I showed you wouldn't get to all of the bearings, so I've had to be using brass drifts and things like that, and various different spacers to try and knock bearings off and out at various places. So they're all done. Just to show you what I'm sort of dealing with, if you look at this one as an example, the paint, this is where they've sprayed through white paint into the casting, with all the shafting and the bearings in place. That's kind of the state of the bearings. So they're all dirty, they're all in various states of being good or poor. So what I'm going to do is get all of those measured up now. Interestingly, the ones that are at the top, the ones that sit in here at the top of the casting, if you want to call it that, the ones that aren't sat in the oil, have this plastic seal top and bottom of the bearings, and they're 1 millimetre thicker. The ones that sit in the bottom of the sump, so these are the ones that sit in the oil, have got a metal seal, and they're 1 millimetre thinner. So again, like I said earlier, I'm not a bearing expert. I don't know much about what goes where and what sort you should have where, so I need to do some research, but I'll try and replace like for like in terms of the way the bearings are made up, and we'll see what we can get to replace all of these. So that's the bearings done for all of the gear shafts. The next job now is to concentrate on the spindle itself and see if we can get the taper roller bearings free out of the spindle, and I have a feeling that's going to need some brute force and ignorance, so I'll bring you back when we're doing that. So I've put the quill up in the vise. What I've taken off is what was sat on here. You'll see this is a spline shaft, and there's a washer here, a tab washer, that looks quite bespoke. So there's a tab that sits in one of the grooves, and then there's various tabs that can be bent over that sit into this this lock nut. So basically, the tab washer was on there in front of the bearing. The lock nut was on this thread, tightened up with the tab bent up into this lock nut to hold it in place at the right, the right tension on the bearing. So I've taken both of those off once, and I've now got to take this off again. It's a nightmare to get off this. There we go. So they're off now. Excuse me, in front of the camera. On the other end, in here, was this ring, which is a threaded ring that sits in the end of the spindle in there, that covers the taper roller bearing at the front end of the spindle. So now there's nothing holding that in other than the tension, that's the preload that's been applied to these bearings, which has basically tightened everything up inside the spindle. So I think, and I don't really know, this is trial and error, I think what I now need to do is tap this end of the shaft to try and create some free play at this end, and then hopefully I can extract the bearing that end, at which point I should then be able to take this shaft completely out, and then I might be able to stick something back through this way to tap this bearing out at this end. So I'm guessing, I'm completely guessing here, so that's what we're going to try. So what I've got is a 12mm cap head and a big washer, and basically I'm just going to stick those over the end there, and I'm going to hit it with a proper hammer rather than a soft dead blow hammer, because hopefully that will be more acute, if that's the right word. It's not the right word, but it'll give a sharper action. So we'll see if this moves anything. Yeah, it's slackening up, so it's obviously moving. Well, there we go. That was easier than I was expecting. I think I might have a bit of sound editing to do there. Save all of your eardrums, but so there we go. There's the top needle roller bearing. It feels reasonable, but when it was as an assembly with both bearings and the preload applied, it definitely felt lumpy. And again, you know, the writing on here is YXHT, which I'm sure is Chinese. Chinese origin is what I mean, because YXHT is what was written on some of the other bearings as well, so it will be a Chinese manufactured bearing. It's obviously been manufactured slightly better than the sort of sealed bearings that I've taken off the shafts, but at the end of the day, these two bearings are the bearings that really matter for the mill. So I'm glad I've got those out. So what I'm going to do is clean those up. I'm going to mark them up with top and bottom just in case they're different. I don't suspect they will be. I think they'll be a matched pair. So I'll do that now, and then I'm then going to make a quick sketch of all of the bearings in terms of outside diameter, inside diameter, thickness, and any markings that's on them. And then I'm going to go and get some research done and get some bearings on order ready for replacement. So really that's the hard work done in terms of the full strip and getting these bearings out and off. The rest of it now is just clean up, getting rid of paint, getting rid of burrs, you know, just a general clean up and tidy up, and I'll show you various bits of that as I go. I'll not show you all of it because there's going to be lots of kind of repetition of the same thing. So we'll do that, and I'll bring you back when we're doing some of that cleanup, and then after that, obviously when the new bearings come, we'll start the final clean and the rebuild process. So you can see I've got all of the bearings out now. So that's the full bearing suite out of the whole head, and the final two to take out were the two taper roller bearings. This one's from the top of the quill, and this one's from the bottom of the quill. So the top one, the bearing knocked out dead easily, and you saw me do that. The bottom, the race, the outer race on the top, that came out okay. There was enough room for me to get the three-legged puller in underneath that and extract that one. The bottom one, obviously the inner race and bearing came out okay because that was on the shaft. The outer race was stuck in the bottom of the spindle. It's interesting to note these are two different sizes as well, top and bottom. You can see there there's a much bigger one in the bottom than there is in the top, which is kind of expect. The bottom one, as I said, the outer race, I tried many different things to get this out and failed. So I reverted back to what I thought I was going to have to do, and I've put in some of my comments. So basically I used my little Dremel with a small grinding point, and I was running that flat out in the Dremel, which I think is about 30,000 RPM, something like that, and just gently, and you can see what I've done there, gently worked away at the bearing race itself, and I was looking very carefully for a change in the material colour. I could sort of see when I was going to be breaking through based on the wall thickness at the front. Obviously I knew it was tapered, so I knew it was going to be a thicker cut at the back, and I was just really closely watching my grind, and it was just do a bit, clean it, do a bit, clean it, until I got to the point where I'd just about broken through, and then a couple of sharp taps and it broke, and at that point it came out very easily. It's the only way I could extract that with the tools and the equipment that I've got here, without buying expensive extractors, and I don't even know with a taper sleeve whether there's something that you can buy to extract those in a blind hole or not. So that's how I did it. I have left a slight witness in the bearing register, both on the diameter and on the register face at the back, but it is absolutely tiny. You know, it's a few thou across the full length, and there's a few thou on the back face where I've just touched the back register. It's not ideal, but it'll have no detrimental effect to the new bearing going in. It would do over time. If I did this 4 or 5 times in different places, then it would start to have an effect, but one tiny mark in that bore won't have any effect at all, so I'm comfortable with it. So moving on to the next stage of the process, I'll just get the spindle itself, and hopefully you'll be able to see. You can see the mark there that I've left in the bore. You see that tiny mark, and on the register at the back. I'll just give that a clean up and make sure that there's no sharp edges. There shouldn't be, but I'll just clean that up before I refit the new bearings. Now, what a problem that there is with this that I've noticed, the central bore of this quill, which does nothing, it's just a clearance bore for the moving part of the quill to go up inside it. It doesn't register on anything, it's in pure clearance. Is a rough cast iron face. So they've obviously taken this as a casting originally. They've cleaned up all of obviously they've done all the machining on everywhere else, so that's all fine. But that bore itself is as cast, and if you put your finger or a rag down inside there, it's you can see it's absolutely full of, admittedly some of this is from me grinding the bearing out, but at this end of the bore it's not, and it's just full of grit and sand, and it's horrible. And what will happen there is, if you think about the bearing that's in this end, the taper roller bearing that's at the bottom, and you look at the back of that taper roller bearing, you can see that where the rollers are is right where all of that crap that's in there, in that bore, if you get some vibration or chatter, or you've got a fly cutter going or something that's going to cause some kind of vibration, all of the rubbish that's in there is just going to fall down straight into the back of that taper roller bearing that's at the bottom of the spindle. So that's terrible. That really is terrible. So before I do the rebuild and as part of the clean-up, this bore, I need to clean that up. Now originally I was planning on putting this in the lathe, chucking it at this big end here and putting a boring bar right the way down and just taking a skim all the way through, which is what I'd ideally like to do. Unfortunately, with my lathe's big enough to do that, but my chuck's only going to be gripping on 1/2 inch at this end, and because I don't have a fixed steady, which is ideally what I would do. I'd have a fixed steady running at this end to support this end of the shaft. I'm not comfortable trying to bore this out in the lathe without any kind of support at this end. I've only got one of these, and if it comes out, I'm going to wreck it, and I don't want to take the risk, which is a shame, because that would be by far the best and the easiest way of cleaning that central bore out. I don't have a fixed steady. There's no other way of me supporting it, so I'm going to revert to sort of manual methods to clean that bore out. So the plan is, my Dremel attachment, or my Dremel that I've got, is here, and I've got this flexi drive that came with it. So the plan is, I'm going to use a flat wheel in the flexi drive, and I can just about get halfway down from both ends with that, and I'm going to clean that bore up using flat wheels inside using the Dremel. It's not ideal. I'd really like to turn it, but I'm not willing to take the risk. It's too much weight swinging around, and it will be unbalanced weight as well, because the quill itself, because you've got the rack machined into it, there's a load of material missing on that side, so the whole thing's going to be unbalanced spinning in the lathe, and I'm just not comfortable with that. That's 12 inches long, 300mm, unsupported. I could probably get away with it, but I'm not willing to take the risk. So that's one of the next jobs I'm going to do, is clean that up. Going back to the bearings, I made a list there of all the bearings, so I measured them all up. So basically, outside diameter, inside diameter, thickness, on all of the bearings based on the shaft numbering, and I've also written down the identification numbers that were on the bearings themselves, and whether they were plastic shielded or steel shielded. I went in the house and did some research, and I've had one or two really good comments about using companies. There's one called Bearing Boys, and there's another one called Simply Bearings. I went on both and did a bit of a comparison, and Simply Bearings came out slightly cheaper. Their website is absolutely fantastic. You go on some websites, and I'm sure you'll have all come across this, and everything's difficult. You've got to try and navigate your way around. Nothing's easy. Honestly, this Simply Bearings website has clearly had input into the web design by engineers and people who understand not only bearings and how they're configured, but also how you'd want to buy them, how somebody like me in a home shop who doesn't have a parts list to go off or whatever would want to try and order bearings up. The website is absolutely fantastic, so easy to use, and within 10 minutes I'd pumped in all the details, got a full list of different bearing manufacturers, NSK, SKF, loads of others, FAG, Timken, all the names that you've heard of, plus a load of other names that I'd not heard of. And I've settled with SKF, so basically I've ordered up a full suite of SKF bearings to replace all of these, and they're now on order. And with delivery, that was just under £100 for the full suite, which I don't think's bad really, considering there's some reasonable sized taper ball races in the mix. So they're on the way, and they'll be here shortly. So I'm going to get on now with a bit more work. I'll film a bit of the flat wheel work inside the quill, and then I'll keep filming bits of the cleanup now while I wait for the bearings to come back. think that's going to do. It's obviously not, you won't be able to see, it's obviously not cleaning up the scale, the casting scale that's on there, but it is taking off. There's no loose, I can't feel any loose sort of sand or clinker or anything like that in there, so I'm going to persevere with that. You know, for how long that's taken, I'm already down almost halfway, so I'll persevere with that. I'll not film all of it, but I'm going to keep going, and then once I've finished, this whole unit then is going to get a really good clean everywhere, to get rid of all of the dust and abrasives and everything else that's gone on around it. So I'll keep going with that, and I'll bring you back when we're doing something a little bit different as part of the cleanup. Alright guys, that's got the quilt on, so I've been all over that now. We've been right down the middle of it, and we've cleaned out as best we can. I'll try and get a shot of that with a camera. I don't know whether it will work, but I'll just try something in a minute. But I've been right through that with a flat wheel now. Everything's been fully cleaned up. I've deburred properly the drift slots for the Morse taper, both sides. I've been all over the rack and cleaned all of the rack up, and deburred where it needed it with a light deburr. Same with the keyway, cleaned up, deburred, put some proper deburrs on where they needed it elsewhere. I've cleaned up my little mark from removing the outer race, so that's just on a light stone. So that's now ready. I'll just reposition the camera and just see if I can get you a shot through here. This isn't cast. I thought I assumed it would be cast, but it's not. So this interior surface, so this is just steel of some sort, and it will have been cold drawn, I'm guessing, into a tube. So this interior surface is that drawn surface, and it's very roughly drawn as well. It's pretty rough in there, but at least it's clean now. I'll just reposition the camera and see if I can show you what that looks like. Okay, so I'll do my best here guys. That's you can now see that interior bore. You know, that's after the cleanup. I don't think the camera's showing it, but it's just black in there, and it's very rough from the drawing process. But that was all covered in sand, and you know, everything that was in there was just going to end up dropping down into the back of the taper roller bearing. So I think that's good enough. So I'll bring you back in a moment when we're doing something else. Right guys, we're just cleaning up these selectors for the gears that should have been done. They've got the horrendous burrs on them, so just a bit of file work. Doesn't take a lot, does it? If you can see this, but this is what could have been dropping off into the sump. Great big bits of burrs really off the back of these. Terrible finish. that's it. That's all it took. Just got to do the hole now, and we'll try this. It's a cheap version of an ogre. There we go, that's that one done, all cleaned up. So I'll do the other one the same off camera, and then we'll move on to the next piece of the jigsaw puzzle.